If you deploy an AI agent for a real enterprise project, you quickly realize it is functionally useless without persistent memory. To actually do meaningful work, an AI has to maintain context from yesterday, last week, and last month. The trade-off is that giving an AI persistent memory means feeding it your proprietary codebase, your internal strategy documents, and your sensitive client conversations. You're taking your organization's most valuable intellectual property and concentrating it into a single, highly vulnerable target. This creates an immediate tension for IT leaders. You need to lock down this sensitive data, but your operators are demanding memory infrastructure right now so they can actually deploy these tools in production. The default reflex for most teams is to rely on standard, centralized, cloud-based AI infrastructure. It has an API, the integration is quick, and it finishes the sprint. Choosing an AI memory architecture dictates who ultimately retains legal ownership and physical control over your most sensitive enterprise data. This quadrant chart maps two architectural paths, Web 2 SaaS versus federated local bridges. The horizontal axis tracks deployment speed. The vertical axis measures data sovereignty. Web 2 SaaS plots bottom right, high speed, high security risk. The federated bridge lands top, slower setup, zero security risk. To choose between these paths, you must ignore marketing claims and evaluate the severe contractual realities hidden inside both models. This comparison matrix breaks down the reality of both paths. The primary benefit of the Web 2 SaaS model is zero-friction, rapid integration. A developer grabs an API key, and the AI agent instantly has a working memory layer. That speed requires accepting click-wrap terms of service. On lower-tier or free plans, you are often granting the vendor a perpetual, irrevocable license to train their own AI models on your proprietary data. Upgrading to a paid tier usually protects your data from model training, and you still get the operational convenience of utilizing their built-in processing pipelines for vector search and data embedding. That convenience creates subprocessor sprawl. Your sensitive data is silently passed through external embedding LLMs, third-party cloud hosts, vector databases, and external error logging services. For a corporate security team, every single one of those nodes requires a distinct security auditing process. You have to individually assess and approve each link in that chain. A multi-vendor pipeline also complicates strict data residency requirements. Proving exactly where your data lives at rest to meet UK or EU compliance standards becomes incredibly difficult when the data bounces across 6 different third-party clouds. Subprocessor sprawl directly multiplies the audit and compliance burden for your security team. The months spent on legal reviews severely erode the initial benefit of a fast deployment. Relying on VC-backed cloud infrastructure inherently means outsourcing all database maintenance and patching to a third party. You also accept the existential risk of vendor insolvency. Standard privacy policies legally allow your proprietary data to be transferred to an acquiring company without your consent during a bankruptcy or asset sale. If the vendor shuts down abruptly, these agreements rarely guarantee a data export grace period. Your AI's memory layer can simply disappear. Standard liability caps in these cloud agreements strictly limit the vendor's financial responsibility. Payouts for a data breach are often capped at your trailing 12-month fees, or sometimes a flat $100. The Web 2 model achieves its deployment convenience by shifting the catastrophic enterprise-scale financial risks of a data breach or a bankruptcy entirely onto the customer. The federated local bridge model operates as a direct structural countermeasure against the vulnerabilities of centralized cloud vendors. Data security is handled via client-side AES 256 GCM encryption. The mechanism uses a key derived locally on your machine, locking the data before it ever leaves your device. This creates absolute data privacy. The broader network only ever receives and stores ciphertext. It never sees plaintext data. This design forces a critical operational trade-off. Your enterprise bears total responsibility for key management. If you lose your private key, your AI's memory is permanently unrecoverable because there is no centralized recovery mechanism. Deployment requires your engineering team to run a local SPV relay bridge, typically deployed via a Docker container or a Node.js process. This local deployment creates a zero-trust connection directly to an immutable ledger. The system is self-healing. The mesh network automatically routes around offline nodes independently of centralized DNS seeds, removing any single point of failure. The federated model explicitly trades away operational convenience in exchange for absolute mathematical certainty over data privacy and network uptime. Writing encrypted memory data directly to a blockchain mesh ensures permanence. Your data becomes immune to corporate insolvency or unannounced changes to a startup's terms of service. This structure shifts the economics away from predictable, flat-rate monthly SaaS subscriptions. The network utilizes a usage-based microtransaction model through the X402 protocol. Data rights are paid in tiny increments of cryptocurrency, meaning you only pay exactly for the storage you consume. There is a secondary financial mechanism built in. Running a bridge allows your enterprise to passively earn micropayments by routing traffic for other applications on the mesh. Adopting a federated bridge transitions AI memory from a rented, vulnerable operational expense into a permanently owned, self-hosted asset. This decision tree highlights the core diagnostic question that should drive your infrastructure choice. What happens to your enterprise if your AI memory provider goes bankrupt tomorrow? If the loss of memory only results in a minor loss of context or a slight operational annoyance, you should use the Web2 SaaS model. If you are a highly regulated enterprise, or you are managing proprietary source code where a vendor shutdown would result in severe IP loss or compliance violations, you must take the alternative path. To take this secure path, you must meet one technical prerequisite: basic internal DevOps capacity to manage a lightweight server or Docker container. If you have that capacity, your recommendation is clear: deploy a local federated bridge. The Web2 SaaS model rents fast memory infrastructure for the price of your data sovereignty. The local bridge model guarantees permanent IP ownership for the price of a slight DevOps learning curve.